Ion electron configurations. First of all, what is an ion? An ion is an atom that has gained or lost electrons. And for these electrons that are gained and lost, they're always the outermost electrons. So it will either lose the outermost electrons or it will gain electrons and put it in the very, very outside of the atom where those electrons are. Metals lose electrons, and they lose enough electrons that they form noble gas configurations. So let's look at sodium right here. So here is the electron configuration for sodium, and when we look for a sodium ion, that is Na+. And we'll explain how I know it's just a +1 and not a +2 or 3 a little bit later on. So notice it is a +1, but you don't write the 1, so you just write a little plus sign there. And that is saying that it lost 1 electron. Now, looking at the atom electron configuration, which electron that's there did it lose? Well, it always loses the outermost. So that's the one that has the highest energy level. So I have an electron there in the energy level 3. So that is the electron that is going to go away. So what is left over? I have 1s2, 2s2, 2p6. So this is sodium ion. So sodium always has 11 protons. And when we have an atom, it has 11 electrons. Now, if it loses 1 electron, I no longer have 11. Now I have 10. So what is the total charge? My total charge is a +1. And that is represented just by a plus sign right by the symbol of the element. All right, so that's for metals. Metals, again, lose electrons. Let's look and see what nonmetals do. Nonmetals, they gain electrons, and they will gain enough that they will form the same electron configuration as a noble gas. So let's look at a fluoride ion. So when fluorine loses electrons, it becomes a fluoride ion. So the name changes just a little bit. So it is going to gain 1 electron. And it just doesn't gain an electron from thin air. It's going to gain from a metal, or just like sodium that we have up above. So if sodium lost its electron, this fluorine atom could gain it and become a fluoride ion. So with 1 electron coming in, my electron configuration would be 1s2, 2s2, 2p6. So if we look at just our fluoride atom, we have 9 protons and we have 9 electrons. So that gives us a neutral charge of 0. But if we go in and if we add an electron, we end up with 10 electrons and an overall charge of a -1. Now take a special look at these ion electron configuration. Here is sodium's and here is fluorides. What do you notice about them? You should see that they are the same. When we have the same electron configuration, these are called isoelectric. So isoelectric means that it has the same electron configuration. Now, does it mean that sodium ion and fluoride ion have somehow become the same substance? No. We still have sodium metal, but just -1 electron, and we still have fluoride non-metal. It's just that it has 1 more electron. Okay. There actually is an element that matches these electron configuration of 1s2, 2s2, 2p6, and that is neon. And what do we know about neon? We know that neon is a noble gas. There's a special stability with having a noble gas configuration. So metals will lose electron to have the same electron configuration as a noble gas, and nonmetals will gain electrons to have the same electron configuration as a noble gas. It's a special stability, a lower energy level. And so that is why there's this electron exchange and why we form compounds, because it makes these atoms more stable. Let's look at transition metals because they do something a little bit special. When you look at transition metals and they lose electrons, remember they always lose the outermost electrons. So take a look at this, stop the video and see if you can predict what the ion electron configuration for vanadium would be. Okay, we're back. So looking here at vanadium, I see that I am going to lose 3 electrons. So lose 3 electrons. There's the number. So where is it going to lose those electrons? So let's look at the outermost. So I do have 3d3 right here, but I also have 4s2. So the correct answer is it's going to lose these 4s2 electrons first. And the reason why is because they are the most outermost electrons. And you can tell that because of the 4. Okay, so it will lose both of these electrons as a group. So both of these will go away, but that's only 2 electrons. We have to lose a total of 3 for our V3 plus. And so it's going to lose one of these D electrons. And so my V3 plus will be 1s2, 2s2, 2p6, 3s2, 3p6, and then of course those 4s2 electrons have totally gone away, and I have 3d2 left. So you could represent an ion electron configuration, the shortened version. So looking at vanadium and going back to the last noble gas, I would put argon, saying that vanadium has everything argon has, plus, so what's left? The 3d3. So that's how you could represent that. So if it seems a little confusing, just know that this portion right here, that is your argon noble gas configuration. So we just have a few d electrons hanging out. Oh, it looks like I wrote that incorrect. That should be a 2. Okay, sorry about that. These ions have specific names. If it's a positive ion, it's called a cation. If it's a negative ion, it's called an anion. How I remember it is a cation has a plus sign in its name, so that T is like a plus sign. And an anion, the word has 2 N's. And so that means it's super negative. But we have 2 ions down here, a cation and an anion. Stop the video, write out their ion electron configurations, and then we'll be back to see if you got it right. Okay, we're back. So looking at our calcium ion, let's compare it to just a normal atom. So that would be argon, 4s2 is how I would write that electron configuration. Now for the ion, that little +2, that tells us that 2 electrons were lost. So what 2 electrons are going to be lost? Well, these ones right here, the 4s2. Those are going to go away, and I am going to be left with the electron configuration for argon. Now the answer is just not argon in brackets. You do need to show the last electrons of that electron configuration. And so what you have to do is you have to go back to the last noble gas, which is neon, and then write everything that you need to get to argon. So 3s2, 3p6. That would be your answer for calcium ion. All right, let's look at oxygen ion or oxide ion. Let's compare it to just the atom, 1s2, 2s2, 2p4. I have a -2. What does that mean? That means 2 electrons are coming in, and I'm just going to tack them right there at the end of that atom electron configuration. So oxide ion would be 1s2, 2s2, 2p6.